Okay, so we're doing ellipse. Remember how ellipse equations work. In fact, let me just remind you real quick. Ellipse equations.
You have to make it look like...
So ellipse, yeah. So it's an egg shape sideways. And this is minus A and plus B, minus B. And the focus points are always on the major axis, aren't they? So that would be like here, C and minus C. The major axis is the bigger direction. So if the thing is more wide, the major axis is the x-axis. And then vice versa, if the ellipse is taller like that, then these points, A, minus A, B, minus B. This is up at C and down at minus C. See how the focus points are on the up-down now? The major axis is the y-axis on that one. So whichever the bigger direction, if it's wider, that's the major axis. Those are also called the vertices. The vertices are the endpoints on the bigger direction. So if it's up and down, then the vertices are up and down. So that's weird, right? Because they use the same word in the parabola section, now with a new meaning in the ellipse section. Let me say that again. So back in the homework you just finished, hopefully, did you finish that? Ton of work. Focus, parabola things. They called the vertex, that was another name for center, huh? Vertex meant center. Now all of a sudden, vertices, that's just the plural of vertex. Vertex singular, vertices plural. Now all of a sudden it means edges, not center.
Well, it's actually the center of each individual parabola. Because they're like two...
Oh yeah, you can think about it that way. That's a good way to think about it. It's like two little parabolas and it's the center for each of those. Nice. Yeah, good. So if that works for you. Yeah, but somehow you have to remember it's not the overall center of the oval. Right? Okay, and then we had a foci. The plural is just foci, right? That's just the plural for two focus points. Foci is just the plural. Anyway, the equation for that is just the Pythagorean, except it has a minus in the middle. Remember, the C is the focus. The A and the B are how far to the edges. Are you with me on that? And that's different, isn't it? Because in the parabola section we just finished, the focus, what letter do they use for focus? What do they use? For focus? Anybody? A, remember? 4A, they'd always have 4A on the right side. They used A for the focus in the last section. Now all of a sudden A and B are the edges and C is the focus. So you got to kind of, that's what's hard about these, is they start using the same letters in new ways and the same words in new ways for the new shape. So we good there? So that's the general game plan for ellipses. They either go sideways or up and down. All right, let's get into the details. So what do you got to do first? The first thing we have to do on this one,
You have to make the right side look like one.
make it a 1. Exactly. See how they always have 1? Oh, I didn't write the equation anywhere. I did all the other less important stuff. This is craziness. Yeah. Let me write the actual most important part. This is x squared over a squared plus y squared over b squared is 1. This one's the same thing, except here the y is got the a underneath it, and the x has the b. Yeah. So, yeah, there we go. And the focus, again, the foci equations are a squared minus b squared is c squared. Good, okay. So there we go. So there's the equations. So let's go back. So you got to get a 1. See how they all have 1 on the right side? Got to get a 1. So divide through by 49. Like that. And then we get what? X squared over 49 plus y squared over 49 is 1. And last thing is we don't want 49, right? We have to make it squares on the bottom. So that's easy.
7.
Yeah, so just make that 7 squared and 7 squared. There we go. All right, so now we're ready to graph that ellipse.
That's not how it works.
Yeah, right. It's what's it going to be? It's going to be a circle, isn't it? Yeah, that's what they're doing on this one. So from the center then, whatever's underneath X is right, left from the center. So go right 7, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. Yeah, so this is a perfect ellipse, more commonly known as a circle. Yeah, it's a perfect ellipse. It's a circle. Because the right and left and up and down are the same. Guess where the focus points are? Let's find the foci. So the foci equation, the two focus points equations, a squared minus b squared is c squared.
It's 0.
Good job. So the a squared and the b squared, that's what's underneath x and y, huh? Everybody good there? Everybody making sense of that? The a squared and the b squared are always underneath x and y. So that's going to be 7 squared minus 7 squared is c squared. That's going to be 0. So root it. The square root of 0 is still just 0. So c is 0. What does that mean, c is 0? That means the focus points, both of them, have come together into the center. The center. Yeah. So the center, the focus is just 0, 0. So that's a weird one because it's a circle, really. All right, let's dive into others. I'm going to move ahead. That's a kind of a strange one.
An ellipse can be a circle.
What do they want? Do they want, oh, they want the vertices. Yeah, what are the vertices? Well, actually, remember the vertices are supposed to be the furthest edges, but they're all four the same. All these are the same distance from the center, aren't they? So the vertices would actually be all four. So 0, 7, this one, 0, minus 7, so this one down here, this is 0, 7, 0, minus 7, and this one over here, which is 7, 0, and back 7, 0. 7, 0, whoops. And minus 7, 0. Yeah, those, all four are vertices, which is weird. Normally we only list two vertices, because the two, it's either wider than it is tall, and the two furthest are wide, or it's taller, and the two furthest are top and bottom. This is a weird one, because it's really a circle. All right, I'm going to move on. Exactly. You're getting the lingo. The ellipse lingo. All right, so try that. So you want to draw a little graph there. And just, you don't need a lot of details, but just put the center, the focus, and the vertex on there. Decide if it goes up, down, or right, left. And then basically what they want in the end, they want the equation. So in the end, they want the equation. See what you can do to get that. So the focus point is 0, 15. And the vertex is 0, 17. And the center is 0, 0. So does this ellipse, this egg shape, oval, does it go up and down more or right and left more? Up and down more, because the vertices and the focus are always on the major axis, the bigger direction. It's got to be up and down, huh? Yeah, so let me draw it. And the vertex is the edge, not the focus. Focus is inside. So it's going to basically sort of look like this. I'll just, good enough. Making sense. That's generally what it's going to look like. Again, the vertex is the edge. Okay, now can we write the equation a little bit? Can we start? X squared over something plus y squared over something is 1. X squared over something plus y squared over something is 1.
Wouldn't the vertex, what's in the y?
Good job, exactly, yeah. So now we need the numbers underneath the x squared and underneath the y squared. whatever's underneath x squared is how far right and left, which I have no idea right now. And whatever's underneath y, remember x is always right left. Whatever's underneath x is always right left. Y is always up down. So what's underneath the y is up. That I can figure out. That's 17, huh? So that's got to be 17 squared under the y.
Root 17?
We good there? What's that?
Wouldn't it be root 7?
No, it's actually the 17 squared.
Okay.
Like that. Yeah, I know it's confusing, huh? Because it's easy to confuse those two. Yeah, it's the number, the height squared, or the distance, I should say distance squared. Yeah, everybody good so far? So the a, see, it's on the board too, if that, keep it before your eyes. So the a squared and the b squared, what goes underneath x and y, are distances, aren't they? From the center to the edge sideways, that's x, up and down, that's y. Okay, so this other one's going to be b. Why do I call it b? Because it's smaller. Remember that A is the bigger one. A is always the bigger, B is always the smaller. So the sideways, you can see the sideways is smaller than the up down, huh? So that's the B. The B, the one underneath X, the sideways is smaller than the up down. Is that good?
So if we know what A is.
Yeah, and this one's A, yeah.
We know what C is.
Yeah, so what are we going to use?
The upside down Pythagorean theorem?
Yeah, the foci equation, which is Pythagorean with a minus, exactly. Yes, this is typically usually what we're going to do, is we'll use the focus equation to find the other. Usually they give you one of them right from the graph, like either the x or the y, the a, and then you find the b by the focus equation. This is typical. So the a squared is the 17 squared. The c, now what's the c?
15.
Yeah, that's right here. This is c. The c is the distance to the focus. So a, b, and c are distances. We good there? So now we can solve for b. Isn't this 289, 225? So subtract 289. Was it minus 64? Divide by minus 1. So therefore, b squared is positive 64. Right, I divided by negative 1, so b squared is positive 64. And then root it. Yeah, b is 8. So bring it back here. This one is going to be 8 squared, and there's the equation. We got the equation. Questions I can answer on that. Is that making sense with what I'm doing? Questions I can answer? I was watching one of my colleagues teach. We evaluate, we watch each other and give evaluation. And so it was good to watch teaching happen for a while from the side. He's a really good teacher. And I was noticing, though, that he would do hard things and then ask. He was doing some pretty hard stuff. And then asking for questions, and nobody would ask questions. But I could tell they should have asked some questions. It would have been more helpful to everybody. So please ask. Please ask. Other people probably are saying, anything I can clarify? Is that making sense?
Yeah, the focus, so the
Yes?
focus is always C?
Yeah, exactly. The focus is always C, yeah. So A and B are always how far to the edges. C is always how far distance to the focus. That's right.
And A's the bigger one, right?
And A is always the bigger. Yeah, so in this case, A is up, down. Sometimes, if it's wider, the A is the sideways. Yeah, A is the bigger. A and B are to the edge. A and B are distance from the center to the edge, up, down, right, left. And C is distance from the center to the focus.
So A we put 17, and if there was a number at the bottom, like at the bottom of that.
Down here?
Yeah.
It would have to be minus 70. It'd have to be the same distance.
Yeah, that would be B then.
No, that's A. Those are both A.
Oh.
Up and down are both A, positive and negative, I mean.
Oh,
And
okay.
right and left are B. This would be B, this would be minus B.
Okay.
Yeah, the right and the left would be B.
Oh, yeah.
B and minus B. And the up and down would be A and minus A. Yeah, good clarification. And the C is the focus, and there'd be another focus down here, which would be minus C. So there's always plus and minus for all these guys. Good on that. Makes sense how we figured that out? Okay, so number 9, they want us to find the equation of that ellipse. Now that one, the center has been moved, huh? So the center has been moved. So let's start by writing the equation. Generally, it's x squared over something plus y squared over something equals 1. Now remember, yeah, you want me to let you draw that? You got a good picture there for yourself. So remember how we, what did we do for the center? What did we do? It's going to be the same thing in all these sections. What we did last time, today, next time, same thing. That is, what do you do with the numbers in the center and how do they show up in the equation?
They opposite.
Opposite, exactly. Does everybody remember that? So this is the x, this is the y. It's going to be opposite in the equation. So instead of x squared, what's it going to be? They have a minus 3 for x, so it'll be x plus 3 squared. And then for the y, they have plus 3 here, so it'll be minus 3 in the equation. We good there? Yeah. So from center to equation, opposite. That's for all these graphing sections. It's always now. Why? Why is that? Well, that's actually like the new 0, 0. Let me show you. If you put negative 3 in for x right here, do you see what that would become? 0. And you put positive 3 in for y, see that would become 0. That's like the new 0, 0. That's why it does that. So that's why it's opposite in the equation from the center. Okay, so we got that. Now, what goes underneath x and underneath y? We can actually just count them off. This is going to be actually an easier one. Do you see what I mean? If you start right here, go 1, 2, 3, 4 to the edge. It's 4 to the right and 1, 2, 3, 4 to the left. So to the edge, it's right and left 4. So where does that go? 4 squared is going to go where? Under what? X or Y? Because it's right left, it's got to go under X. Does that make sense? Whatever's right left has to be X. Up down has to be Y. Yeah. Good. And then what goes underneath Y? Yeah. How far up and down? 1, 2, 3 up. Up 3 and 1, 2, 3 down. So it's up 3, down 3. So 3 squared, and we're done. We got the equation. So we didn't even need to use the other focus equation on that one. We just counted them off. Right and left 4. So 4 squared under X. Up and down 3. So 3 squared under Y. And there we go. All is well?
I think that was deceptively easy.
Yeah, that one's not bad. Okay, so try that one. So what do they want? They want like everything in the world. They want the vertices, the focus points, the graph, the center. So let's start with the center. That's really where we should start. So the center. So what's the center of this graph? Yeah, remember you'd always do opposite. So it's going to be right 2, down 3. So there's the center. Opposite. Now from there, we're going to go right and left to the edges, up and down to the edges. So whatever's underneath X, 6 squared. Whatever's underneath Y, 2 squared. So whatever's underneath X is right and left from the center. So how far right and left do we go?
So from
6, huh? So I'm going to go 1, 2, 3, 4, 5, 6. So I went right 6 and then go 1, 2, 3, 4, 5, 6. 6 left. So I went right 6, left 6. Is that making sense? And then whatever's underneath y, that's up, down. So up 2, down 2. And we got our oval. Like that. So the cookie? I thought it was a big eyeball. All right. So now, is that good for the general graph? Everybody see how we did that? So I found the center, opposite, and then whatever's underneath x, 6 squared, right 6, left 6, underneath y, 2 squared, up 2, down 2. Now they want you to find the vertices, the edges. So where the furthest edges. When they say vertices, they mean the furthest edges. So which ones are the furthest edges? Right, left, or up, down?
Right.
Yeah, this one here and that one there. Now, how are we going to find that? Here's the easiest way. Rather than counting everything and stuff, I think the easiest way is to just start with the center, because it's always from the center, huh? We're always jumping off from the center. So start with the 2 minus 3, the center. And remember what we did from the center to get to the edges? We went right 6 and left 6 from the center. So I added 6 and subtracted 6 from the x coordinate, because it was right left. Now if I had to go up down, I would have done the y coordinate. We'll do one of those in a minute. Everybody good there? So you add 6 and subtract 6. So what do you get? So the vertices then are going to be 2 plus 6, which is 8, negative 3, comma 2 minus 6, which is negative 4, comma negative 3. There they are. So this one is 8, negative 3. This one is negative 4, negative 3. So we got the two vertices. Last thing, they want the two focus points. Can we find the two focus points? First off, in general, where are they? Are they sideways or up and down? They're always on the major axis. Remember, everything's always on the bigger direction. So they're sideways. They're like maybe here and here or something in general. I'm just giving us a feel. Does that make sense? They're sideways from the center. They're right and left from the center. Sideways from the center. So how do we find those two spots now? Yeah, so we got to do the focus equation, huh? So let's go do the focus equation. Maybe I'll just go over here with a fresh screen. So the foci equation, which is Pythagorean with a minus. What's A and B? A and B are the 6 squared and the 2 squared, huh? A squared and B squared are always underneath X and Y. Now, when you subtract two things, you got to put the bigger one first. Don't you? That's why I wrote A is bigger. A is always the bigger one. So this is A, this is B, huh? A is what? Why? Because you got to start with the bigger one. You subtract, you got to start with the bigger one. So it's going to be 6 squared minus 2 squared is C squared. Yeah. Like that. So that's 36 minus 4. That's 32. How do you solve for C there? Root it, plus or minus. And anyway, how do you simplify square root of 32? Remember from algebra, simplifying roots?
Yeah.
Do it up here real quick.
Plus or minus
4 times 8, yeah, 2, 2. 2 times 4, 2, 2. So I ended up with 5 2's. 1, 2, 3, 4, 5 2's. So square root of 32 is the square root of
2 times
1, 2, 3, 4, 5 2's. And then what do you do to simplify that? 2 for 1. Remember, square roots are a 2 for 1 deal? Do you know what I mean? Like, you guys know the square root of 9 is 3. What just happened there? There's 2 3's in there, right? Isn't that what 9 is? 3 times 3? See how there were 2 3's inside but 1 outside? That's what square roots always do. I always tell my algebra students, like going to Target, it's a 2 for 1 deal. Things are on sale 2 for 1. That's what roots do. That's why it's called a square root. It's 2 for 1. So 2 2's in, 1 2 out. 2 2's in, another 2 out. They multiply on the outside just like they were on the inside. 2 times 2 is 4. The other 2 has to stay in. 4 root 2. Plus or minus 4 root 2. Is that good? That's simplifying that. So we go back and we say, okay, C is plus or minus 4 root 2. What is C again? It's the distance from the center. Remember, the center is the jumping off point. From the center, either right, left, or up, down, whichever direction's bigger. In our case, right, left. I think right, left, right? Yeah, right, left. To the focus points. So A and B are distance to the edges. C is distance to the focus points. So that means right 4 root 2 and left 4 root 2 to the focus points from the center. So how do you do that? So we just take the center, which is 2 minus 3, and you just go 2 plus 4 root 2 minus 3 and 2 minus 4 root 2 minus 3.
So one's an exact answer?
Yep. Yeah, just like that. With a comma between them. Done. Is all well? Is that good? That makes sense what I did there. Why did I put the plus 4 root 2 and minus 4 root 2 on the x coordinate? Because it was right, left. Everything was x on this one because the major axis was sideways. The bigger direction was sideways. We'll do one in a minute that's more tall, up and down.
Does it matter that, like in that picture, that the B is on top, it's a positive B, but right here, would it be a negative B?
What's that?
On top of the edge? Like, you know how it's on the negative side of the graph?
Oh, yeah, no. Yeah, good question. Yeah, this one's centered at 0, 0.
Yeah.
Yeah, so that's going to be a negative number. So you're right on this one. Yeah, B would actually be well, I should say B is a distance. B is technically a distance. So B is always positive. So B would be the jump, the distance on that one. Yeah. We good there with that equation? Is that making sense? But the coordinates would be negative, Naz. Yeah, whatever that, we don't have to find it. But whatever that dot is, that'd be some negative coordinate. You're totally right. Yeah. But B's not a coordinate, it's a distance. We okay? All right. This one's going to be really long. Here's the deal. When you when you have x squared and x to the first, you must make it become x plus a number squared. Same thing for y.
So you're going to complete the square again.
Complete the square twice here. For both x and for y. Does that make sense, what we're saying? Both x and y, we have x squared and regular x, y squared and... Oh, wait, I messed that up. That's supposed to be 54y, sorry. 54y. Let me rewrite that. 54y plus 9 equals 0. Yeah, so we have x squared in regular x, we have y squared in regular y. So when you have that, you got to complete the square. You've got to make it a square, a parenthesis square. So, right, we did a little bit of that with the parabola. So how do we do it? Step 1. Organize everything organize x squared and x, y squared and y, and move numbers to the other side. So I'm going to take that plus 9,
Make it -9.
do minus 9 from both sides, so it's gone. So right now, step 1, I'm just kind of organizing things. I'm just going to say, all right, get the x squareds all organized, get the y squareds all situated, and that plus 9, move it to the other side, becomes a minus 9. We good there? I just subtracted 9 from both sides.
That's kind of weird.
Now, so that's step 1. Organize x squared with x, y squared with y, move the numbers to the other side. Next, step 2. Factor, this is new. We didn't have to do this last time. This is more complex. Factor out numbers in front of x squared or y squared. So any number in front of x squared or y squared needs to be factored out. Do we have numbers in front?
Yes.
Yeah, we do for the y squared, don't we? So the x squared will stay as it is. Factor out the 9. Is that good? Factor that out. Now, we're going to do step 3. Number next to x over 2 squared add to both sides. So the number next to x, and you can do the same thing for y. Right, that's how you find the completing number. It's the number next to x over 2 quantity squared. Add to both sides. So let me let you do that real quick.
9.
Oh, how are we doing? Okay.
No, that's okay.
So you grab that number right there next to x, put it over 2 squared, which is minus 3 squared, which is plus 9. And then you add 9 to the left side, but you have to also add it to the right, so you're not changing the equation. Right? We have to keep the balance, right? Got to do the same thing to both sides. Keep the balance. All right, now do the same thing for y, but think carefully. Something different's going to happen for y. Think just make sure whenever you do on the left side, you truly do the same thing on the right side. And I'll show you, but let me give you a second to try it. So go ahead and do the y here. Same thing. Take that number next to y, 6, right? Over 2 squared. So take that number next to y. So that's 6. Same deal. You know, whatever's next to x or next to y, put it over 2 squared, which is 3 squared, which is plus 9. These are always positive, by the way, because they're squared, huh? These completing numbers are always positive. Plus 9. Now, where's it go? Well, right there. It has to go in the parentheses because it's all part of the y deal. Now.
You add another 9 for the other.
Am I losing you there?
Yeah.
So for both x and y, we grab the number next to x, put it over 2 and square it.
Okay.
Add that to the left and the right. Why am I doing that? Because then these 3 will factor beautifully. That'll be x minus 3 quantity squared. That'll complete it. That'll give it exactly what it needs to factor as a square. Now, same thing for y. Grab the number next to y, put it over 2 and square it, plus 9, put it by y, because then these 3 will factor beautifully. That'll be y plus 3 quantity squared. It'll complete it, gives it just what it needs to factor as a parenthesis squared.
But now don't you have to add?
But this is where we got to be really careful and really truthful about truly doing the same thing to both sides. Whatever I just did on the left side, however I truly, not just visually, but truly affected the left side, I've got to truly affect the right side. What did I, by putting a plus 9 right there that wasn't there before,
81.
I really raised the left side by 81 because he's under the influence of that 9. You've got to add 81 to the right side. Let me say that again. Do you see that? You got to think about any changes you make to the left side, what they're really doing to the left side. Right? Think with me. Let me back up and show you. Right? This plus 9 wasn't there before. Right? And this 9 wasn't there. Let's go back. Right now, at this point, everything's as it has been from the beginning. I haven't brought anything new in yet. Right? The x squared minus 6x. That was there from the beginning. That's not new. If you distribute this will be 9y squared. 9 times 6 would be this. That was there from 9y squared, 54y. This is the same. This isn't new. This is just factored. But this isn't new. But now, when I write in that plus 9, that's brand new. That was never there. So I had to do plus 9 on the other side. Great. That one you've got. But what about this plus 9? If I was to multiply this back out, what would I have here? 9y squared plus 6 times 9, 54y, which was already there from the beginning, plus 81. There would be a brand new 81. That's what I really did to the left side by adding this brand new 9 under the influence of another 9. He's like a drunken driver. He's under the influence. I just try to say weird things every now and then to stick it in your mind. Right? Is that he's under the influence of another number. So when he's a drunken driver like that, you got to treat him with care. Right? That's a new 81 on the left side. Really, that's the effect, huh? I really raised the left side by 81. So I got to also truly do the same thing to the right side. So I don't change anything. I'm always doing the same thing to both sides. All right. So now, let me bring it to a fresh screen. What do we have here? X squared minus 6x plus 9, then a 9 factored out. Y squared plus 6y plus 9, minus 9 plus 81, I think. Yeah. So we have all that, right? And then these 3 are guaranteed to factor. That's what that completing number, divide by 2 square thing, that's what it does for us. It makes it factor perfectly. See, isn't that true? Isn't that x minus 3 if you FOILed that out? See how it would be minus 6x in the middle, negative 3 times negative 3 is plus 9. See how it made it a parenthesis squared? And now for the y, same thing. This is going to be y plus 3 because that makes plus 6y in the middle and plus 9 at the back. So that's y plus 3 squared. Other side, these cancel, 81. We're so close.
Divide by 81.
Yeah, last step, you got to make a 1. We got to make it look like, got to have the right look in the end so we can do our graphing thing. So yeah, you got to make the right side be 1. Right, all these equations, right side's got to be 1. So divide through by 81, like that. So it makes that right side 1. This left side now becomes x minus 3 squared over 81. Everybody good so far here?
That's not good.
So what's going to happen? Now what's going to happen? Everybody tracking with me? So what's going to happen here? 9 into 81? 9 times. Good there?
Do we need to square that?
Yeah, and last thing, make those squares. So 81 is 9 squared, 9 is 3 squared. There it is. Now we're halfway through the problem. After all that, now we would have to graph. I don't want to do any more on this one. I'll go dot, dot, dot. You would know how to do it from here, right? You would have to find the center, go right and left, up and down, make the graph, find the vertices, find the foci. All that stuff we did in the last problem begins now on this problem.
What's wrong, Mr. Hearn? You only did one hard problem?
Well, if we do that, I won't do those bridge problems and the whispering gallery word problems
No.
at the end.
If I took that attitude towards my homework.
Yeah, there's a limited time and questions. That all making sense? Anything I can answer for you? You good with all that? Want to try one of those? Through all the steps. This one needs everything. So gather up the x squared, the x's, gather. So first step is organization, right? Just get the x's together, the y's together, push the numbers to the other side. Then factor out the number in front of x squared and the number in front of y squared. Okay, so I'm going to start by subtracting 36, right? Because we want to push the numbers to the other side. And then I'm going to get the two x's together and leave a blank. Get the two y's together and leave a blank. We good to there? So see how I just kind of organize things first off? Got the x's together, the y's together, and push the number to the other side. Okay, now we're going to need to take out the 36, factor, right? Take out the 9. Use your calculator, some ugly numbers here. Good to there? So you factor out the number in front of x squared and the number in front of y squared. Okay, now you need to find the completing numbers. Right? Take the negative 2 that's in front of x, put it over 2 parentheses squared. And take the plus 12 that's in front of y, over 2 parentheses squared. Find the completing numbers.
Yeah, that's how you solve that. You don't put 9
Yeah, no, I was confused at
Yeah.
first. So I brought it back to this crap.
I didn't even know that. So. For
Feel
example,
dumb. It's just, I
I
was like,
feel, yeah, I always feel dumb. Always.
you realize it after you make the mistake.
Mm-hmm.
Because now we're
Mm-hmm. 3 plus 1. Right. 3 plus 1.
So take the minus 2, put it over 2 squared, minus 1 squared, plus 1, huh?
Yeah.
The completing numbers are always positive because they come from squared. So plus 1. So you put a plus 1 right there. But by putting a plus 1 right there, he's under the influence. He's a drunken driver. Is he under the influence of the 36?
So you have to add 30.
So I've got to really add 36 to the right side because I really added 36 to the left by putting that plus 1 under the influence of a 36.
Is the first series of numbers always supposed to cancel out?
No, that's just coincidence.
It happened last Tuesday.
I know it has. All right, the next one. Take the 12, put it over 2 squared, which is 6 squared, which is plus 36. Put the plus 36 right there. Now that's a plus 36 under the influence of a 9,
So 324.
which is 324. Does everybody see where we came up with that? 9 times 36 on the calculator. Or just ask Rachel. She knows. 324. Is that good? Does everybody see how I'm doing that?
No, I am.
Is that good? Now, those things should factor. They will. They'll factor as parentheses squared. We gave them just what they need to complete them and make them factor as parentheses squared. So bring it down. Everybody tracking with me? This is going to factor. Okay, x minus 1, huh? Because that makes minus 2x multiplies to be plus 1. So make that x minus 1 squared. We good?
Yes.
Plus 9, and what's the y?
Plus 6.
Plus 6, right? Because that'll make 12x multiplied to be 36, huh? So that, see how this is working beautifully? The other side, these cancel. 324. All right, last step to give it the look we need. What do we need on the right side?
A 1.
Always a 1 on the right side. So whatever number you have on the right side, divide everybody by that number to force a 1 on the right side. You gotta have 1. Ellipse equations, we always have 1. Be the same thing next week with the hyperbola. Gotta have 1 on the right side. So divide through by 324. And then use your calculator. 36 into 324, was it 9 times?
Yep.
And 9 into 324, 36 times. Like they trade, huh? And this is 1. Everybody see that? And what is the 9?
3 squared.
3 squared. And what is the 36?
6 squared.
6 squared. All right, let's go on. Let's do this one. Let's complete this one all the way. Let's graph him now. So to make the graph now, find the center. Start with the center. Remember, opposite, opposite. Find the center and then find the vertices.
1, -6. What else are we looking for?
Wants the vertices and the focus points.
Oh,
It's ready. I'll move this to a fresh screen if you're okay with that and start doing the graphing. You got this stuff down, so it's going to be x minus 1 squared over 3 squared plus y plus 6 squared over 6 squared equals 1. Okay, let's go to the graph. The center. So the center is going to be, remember, it's opposite for the center, over 1 down 6. Everybody good with the center? Opposite, over 1 down 6. And then from that center, whatever's underneath X, right, left, what's underneath Y, up, down, to the edges.
Oh, 4 vertices?
So right, left, 3. 1, 2, 3. 1, 2, 3. We good? So whatever's underneath X, remember X is always right, left. Y is always up, down. So up and down 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we can make our oval. Like that. That good?
Yes.
It's all making sense.
How do you know if it's a squared or b squared?
Yeah, don't get too hung up on the A and the B. I know that can be confusing. Just remember, if it's under X, it's right, left. If it's under Y, it's up, down.
Okay.
Yeah, and the A is always the bigger. So that's one other rule. The A is the bigger of those. Yeah. So but the main thing to remember, if something's under X, whether it's A, B, Joe, Tom, whatever, it's right left. If it's under X, it's right left. And if it's under Y, it's up down. Always. That'll always be the case. So yeah, we can just count on that. And then now from here, they want the vertices. The longest, those are the longest edges. The longest edges, the furthest away edges. So see if you can find it. Where are those going to be? Top and bottom or right and left? Yeah, it's right here. So now I'm giving you one that goes up and down. That's why I wanted to do this one in particular. So this one's up and down. The vertices are those two dots, aren't they? Because that's the major axis on this one's up down. That's different than the last one we did all the way out. The major axis was sideways. So this one's up down. So you want to find those two. Now, let me help you with that. What's the easiest way to find those? There's a lot of ways. I found it's easiest over the years to just start with the center, which is 1 minus 6 right here. 1 minus 6. And then just because you're jumping off from the center, aren't you? You're going up 6 and down 6. Isn't that what we did, right? Because that's what's underneath Y. Right? From the center, we went up 6 jumps and down 6 jumps. That's what's underneath Y. Y is always up, down. So therefore, just come over here and simply add 6 and subtract 6 to the Y coordinate. This time it's the Y coordinate because up, down, huh? Remember last time we were going sideways, we did the X coordinate. So what do we get then? That'll make this one become 1, 0, which sure enough, that is 1, 0, isn't it? And the other one will become 1 minus 12, and sure enough, that is 1 minus 12. There's the two dots that are the vertices. Finally, can you find the two focus points? So find the two focus points. Use the focus equation, the Pythagorean with the minus. Now, what are the a squared and the b squared? Yeah, it's the 6 squared. It's the things underneath x and y, huh? And the a's got to be the bigger because you're subtracting. So the bigger has to come first. So 6 squared minus 3 squared. So that's 36 minus 9. What is that? 27 is c squared. Root it. Plus or minus. We put a roof on the house. Plus or minus. What's root 27? 3 root 3. Everybody okay with that? Because 3 times 9, and the root of 9 is 3. So 3 root 3. Okay. But remember, that's just the distance. A, B, and C are just how far, distance from the center. So you got to go to the center now, and you got to jump a distance plus 3 root 3 and minus 3 root 3. Yeah, so where are we going to put that? Yeah, they're always on the major, everything's always on the major axis. The vertices and the foci. So which one's the major? The up, down, huh? Yeah. So that means I'm going to go from the center and I'm going to jump up 3 root 3. I don't know exactly where, but I was going to put a dot anywhere. I don't know. And then down 3 root 3. But it's up, down, not sideways because the major is up, down, huh?
But it wants an exact answer.
It does. So we got it. So what do? Then you take the center. It's all going back to that center again. So take the center. I'll write it right here, which is 1 minus 6. And I'm going to add 3 root 3 and subtract 3 root 3 from the y coordinate because up, down, huh? So what's that going to be? We're so close. It's going to be 1 minus 6 plus 3 root 3 and 1 minus 6 minus 3 root 3. Done. It's just as easy as that. Those are the foci points, and we are finished. We found everything in the world starting from that super messy equation. We cleaned it all up, put it in right form, found everything. Yes.
Do we put it like that in the...
Yeah, it's exactly how they want it typed in. They want the two foci with a comma in between them.
You wouldn't add it or subtract it.
You can't because they're not like terms. I don't know if you remember from algebra, but if you have 6 root 3 plus 7, you can't add those. If that had a root 3, then you could add them. They have to have the same roots. But if you just have 6 root 3 and 7, they're not like. Yeah, they have to have the same. It's kind of like 6x plus 7 or something. You can't add them unless they both have an x, unless they both have a root 3. Yeah, so this just stays like this, and this just stays like that. We good with all that? What was that, 15, 20 minutes? For that one problem. So is this what you signed up for with pre-calculus? Oh, this is hours of work, isn't it?
Yeah, cat will be worse.
We good? Questions I can answer? Does that all make sense? All right. So there we back 2 up to 1, 2, 1, 2, and 1, 2, 3, 4 up to. So there's a vertice. And there's a vertex and a vertex. And the focus point is right there. 3, 2, that's a focus point. Okay. We good to there? Just kind of putting the dots on the graph. And then let's draw as much as we can, because this helps us think right, I think. Is the oval going to go sideways or up and down?
Sideways.
Yeah, because the vertices are the larger, furthest edges, huh? So it's got to be a sideways one. So last one was up and down. We're back to a sideways one. And you all know that the focus is inside. That's for all these graphs, just like it was for the last section. The focus was inside the satellite dish, right? Same thing here. The focus points are always inside the oval. When we do hyperbola Thursday, it's always inside. So they're always inside. So the vertices are the edges. They're the longest edges. So this one's wider. Okay, so now from there, can we come up with the equation? Can we come up with the equation? Well, let's just start writing. We know it's x squared over something, y squared over something is 1. Just start there. So to get much further, we really need the center of this thing. That's the weirdest part of this one, is they haven't given us the center. Can we find the center?
Well, yeah, we're gonna have to.
You know it's on this line, huh?
Yeah.
Because everything's on that line. The focus points versus everything's on that line. That's the major axis. But where exactly? We need to know the sideways. So we know it's up 2.
It's going to be the same distance away from -2 that it is away from 4.
Yeah. So here's the left edge. Here's the right edge of 4, huh? I just grab that -2 and that 4. Yeah, that's the left edge, right edge. So the center has to be in the center of M, doesn't it? The middle of -2 and 4. Now, this one you could probably just eyeball, because it's not very big numbers, but I'm telling you, sometimes they'll give you like -17 and +36 or something. So you're not going to be able to just eyeball it. You need a game plan. How do you find the middle of 2 numbers?
The distance.
How do you do it, Abdul? And?
Divide by 2.
Yeah, it's like if I said, hey, you got a 70 and a 90 on your exams, what's the middle? Add them and divide by 2. It's average. Yeah, average finds the middle of 2 things, doesn't it? Add them and divide by 2. Yeah, so just take -2. Let me scribble it over here on the side. Just take -2 plus 4, divide by 2, which is 2 over 2, which is 1. 1 must be. It doesn't look like it on my graph. Doesn't look so good. But right there, out 1. So the center must be over 1 up 2. That's the center of the ellipse.
So we just take that, and that's what x is plus.
Good. Good. So put that in. So now we have the center. Now we can start rolling this thing out. So can you come up with the equation? Give you a second there. All right. So what do we do with the center in the equation? It's opposite, huh?
Yes.
Good there. Start there. So it's going to be, so here's the center, so it's going to be opposite of 1 and opposite of 2. So x minus 1 squared, y minus 2 squared over, well, I don't know what it's over yet, over something, equals 1. We good so far? Opposite, opposite. Opposite of 1 is minus 1, opposite of 2 is minus 2. Good. Now, how do we find out what goes underneath? Well, what goes underneath, remember, is how far right and left or up and down to the edges. To the edges. So how far from the center to this edge? 3. Good. We're going from 1 to 4. So that's 3 squared underneath x. We good there? Everybody okay so far? So remember, from the center, right and left to the edges is under x. Up and down to the edges is under y. Now, how far is up and down? I have no idea. Just call it b and use the focus equation. Right? We don't know what it is. It's b because it's the smaller. Remember, a is always the bigger, b is the smaller. I can't tell on the graph. They didn't give me those dots up and down, did they? So I used the focus. It's pretty typical. This is pretty much what we almost always do, is use the foci equation. So a squared, it's the Pythagorean with a minus. What's the a squared?
3.
3 squared, good. Minus b squared is c squared. Oh, and I know the c. What's the c?
1.
What is it?
No.
No, it's not the focus point.
Focus.
Is 3, 2.
Yeah, it would be.
That's the point.
It's how far from 1, 2 to 3, 2. It's 2. Does everybody see that? Let me slow down a minute. The focus is at 3. It's how far from 1 to 3. C is the distance from the center to the focus. Remember that?
13.
A and B are center to edges. C is center to focus. Right? So how far from 1 to 3? Because the focus is at 3, 2. The center is at 1, 2. So how far from 1 to 3? 2. Everybody tracking with me on that?
We don't have the b squared, we do the...
Yeah, pretty much. We'll have one exception to that. In a minute, they're going to give me a point on the graph. That'll be, but almost always, when you don't have the b, well, how about this way? If you don't have the b, but you do have the focus, for sure, use the focus equation. Yeah, that's probably the clearest way I can say it. If they're giving you the focus, you're going to use the focus equation. Just count on it. Yeah, if they give you the focus, see in the very beginning of the problem, they gave me the focus right on step 1. You should think, I'm going to use that focus equation at some point. Absolutely.
I said it correctly.
So we use the focus equation. Going to get 9 minus b squared is 4. Subtract 9. Minus b squared is minus 5. Last step, divide by minus 1. B squared is 5. Root it, root it.
Did you have them? You had them.
B is the root of 5, huh? We good? Come back here.
I did.
Root of 5 squared. Done.
That should be minus. That should be minus. Right here. Oh, right here. Because when you do the
Is all well.
A squared plus b
because you have to
squared
subtract it.
plus c.
Does that make sense what I did there? I just solved, right? The bigger was the sideways, so that's a. A squared's the bigger, b squared, a squared minus b squared. Solve for b squared's root is 5, square root it, b's the root of 5. Everybody see why b's the root of 5? Right, because b squared is 5 here. Kind of ran out of room. B squared is 5. So then I root it,
Plus or minus.
b's the root. Yeah, plus or minus, but it doesn't matter. Plus or minus root 5 squared is still going to be the same thing. So we just say root 5. Because it's squared, it covers all the signs. Makes them all positive. So there we go. Are you doing okay on this? Questions I can answer?
It's just long.
It is very long.
No.
Okay, the equation. So can you start with a graph? Draw a graph. But notice they're not giving me the focus, huh? See how that's different? All the other ones, pretty much they give me the focus. No focus here, so we're not going to use the focus equation. We're going to use that point in the end to plug in, right? Because a point you can always plug in. It's got to make the equation true. Wendy, you snuck in. You're here. Did you just sneak in? Huh? Wendy will do these problems with you for hours. Yes, and she'll enjoy it. That's what good tutors do. I remember when I was first a new teacher, I learned that if I just did problems for people when they came to office hours, I wasn't very much help to them. And I didn't really know what their questions were, but when I said, well, show me what you do, and then I would see right away. When they would try it, and I would see where they would get stuck. Oh, okay, you don't need me to tell you all this other stuff. You know that. You just need me to tell you this. Yeah, that's exactly right. So it sounds like Wendy will be helpful to you. Come see me or Wendy. Get these worked out. You can ace this stuff with enough time. And you got nothing but time, right?
Sure. That's why I can't take this one next semester.
Can't take, which one you're not taking?
This one.
Yes, yes. I didn't think she was outrageous in homework, but maybe so. All right, let's see. Okay, so back one up 4. Back one up 1, 2, 3, 4. Right there. 5, 6, 7, 8, 9, 10 is the vertex. So we got the -1, 10. There's the vertex. And the center right here is -1, 4. Center. Okay. So is this thing going up and down or taller or wider? Up and down. Because the vertexes are always the furthest edges, aren't they? The edges on the major axis, right? Okay. So it's way up here and probably goes down there and something like that, right? Okay. So they want the equation. So let's just start writing the equation. Just start cranking it out. X squared over something plus y squared over something is 1.
Okay.
Good to there?
We can revise that.
Okay, now, yeah, we have to shift that. That's not right, huh? I got to shift for the center, don't I? I got to do opposite. If I leave it like that, that would mean center 0, 0, huh? I've got to shift it because you got to do opposite, huh? That's right. Sometimes I forget that little piece. So x plus 1 squared, opposite, right? And the other one is going to be y minus 4. That's right. Okay, good. Now, so opposite. Now we have to find out what goes underneath x and what goes underneath y. Remember what they are. They're how far to the edge, huh? What goes underneath x is how far right and left to the edge. Underneath y is how far up and down to the edge. Do I know either one of those right now?
Yeah.
Yes, I do. What do I know?
The center, the y center is 4, and then I'm trying to find how far it is to 10.
Yeah, exactly. Everybody good with that? If we're going from a height of 4 to a height of 10, that's 6. That has to go what? Under x or under y? It's up, down. Has to go under y. Remember, it's distance. Remember, what goes under x is distance from the center to the edge sideways. Under y is distance up and down. Okay, so we got that. What we don't know is the other one. The other one is b. Because remember, a is the bigger's up, down. So the bigger is the y. This is the a, because it's the bigger. Remember, a is always the bigger direction. B is the smaller direction. So the up and down is bigger, the sideways is smaller, so the x is smaller. Anyway, whatever. I'm not going to use the focus equation now. Why? Because I don't have the focus. See how they didn't give me the focus? This is what I normally do. Normally at this point I break out and write the foci, the Pythagorean with a minus, because normally they give me the focus. And I plug in c, which is the distance from the center to the focus. I don't have that. I don't know that. That won't do me any good. I won't go anywhere with that. So what do I do instead? Ness? Okay. Use the point. What do you want to say, Ness?
Can you find the focus?
Later, not right now.
Isn't it just the point between the center and the vertex thing?
The C? The focus is going to be somewhere like here, basically. Somewhere inside before I get to the vertex.
Okay. And it's not in the middle of the two numbers?
See, the focus points are always inside.
Yeah.
Inside, not right in the middle. No, not exactly in the middle. Is that what you meant?
Yeah, that's what I was.
No, it's closer to the edges.
Okay.
Yeah, it's not right in the middle. I see. You could just average them that way. Yeah, no, it's not right in the middle. I see what you're saying. Yeah. So instead, I'm going to plug in this point right here, and this is x, this is y. Plug in x is 1. Right? That making sense? X is 1. Y is 4. X is 1. Y is 4. Has to make the equation true, doesn't it? Because 1, 4 is on the graph. The graph contains the point. 1, 4. Any point on a graph makes this equation true. So if I plug in 1, I get 1 plus 1 squared over b squared plus 4 minus 4 squared over 6 squared is 1. Is that making sense so far? So I'm plugging in 1, 4. 1 for x, 4 for y. What do you get then? 2 squared over b squared. What's this? 0 squared over 6 squared. That's just 0, isn't it? That's just gone. 0 over anything is 0. So this becomes 4 over b squared is 1. So far, so good?
How is 4 over b squared 1?
So we gotta solve for b. Can you just see the answer? What's b got to be? 4 over what is 1?
4.
B's got to be 2. Yeah. 4 over 2 squared. 4 over 4. But anyway, I'll go through the formalities. It might not always be so obvious. So how do you formally come up with b's got to be 2? You know. But how do we do it? Put this over 1, diagonal, diagonal. Remember when you have a fraction on one side? Hold on, put over 1, diagonal, diagonal. 4 times 1 is 1 times b squared. 4 times 1 is 4. B squared. So how do you finish solving for b? Root it. Plus or minus, but we don't care because it's going to be squared. B is 2. B's got to be 2. So bring it back. We got our b. B is 2 squared. Plus or minus, but plus 2 or minus 2 squared either way is 4. So there it is. There's the equation. Is that okay? Is that too fast? You guys are looking shocked. Maybe just tired.
Just a lot.
It is a lot.
Different ways to do a lot
Yeah,
of things.
it is. And each problem's long.
We did the whole river problem today in calculus, the fence around the river.
Oh, yeah. Like we've done it here,
Yeah.
but you guys do the maximum minimum by hand, by the derivative. Yes. That's right. No graphing calculator. Just throw this thing away when you're done with this class. That's right. Everybody seeing what I'm saying? It's got to be 65 to the right and 65 to the left because it's 130 feet. That single mark means feet. 130 feet total width. So that's 65 each way. 65 each way because it's 130 total width. And that's underneath x because that's right and left. So we got that. Now, how far up and down? How far from here up? That's called B, isn't it? This is only half an ellipse. We don't have the bottom half. They didn't make the floor elliptical.
So then why
So-
don't we do it as a parabola?
So basically, we need to just find the B. Good question. Renee said, why can't we, isn't it just an upside down parabola? Actually, the curvature rate, even though, yeah, it looks like it is an upside down U, the rate of bending is different. It's different. Even though you think, well, they're all just curves. Yeah, but they're different kind of curves. So in other words, a parabola is not exactly half an ellipse. If you put two parabolas together, you won't really get an ellipse because the curvature is different. That's a good question. Everybody know those curvatures are actually different. It's not just half the size. It's the bending rate is different. For parabola, ellipse, and then tomorrow or Thursday, hyperbola. So anyway, so I got to find the B is basically what they want me to find. That's the height above head level, right? The h is the b. They want me to find it. So I need to take that equation and find b, don't I? How am I going to find b?
You can put it,
Yeah, because I know what?
you know, the focus point.
I know the focus point. These people are standing at the focus points. That's C. C is 30 feet from the middle to the focus, from the center to the focus. That's C, isn't it? So I can set up the focus equation. So the focus equation, a squared minus b squared is c squared. The focus equation, the Pythagorean with a minus. So what's the a?
65.
65 squared. Looking for the b, the c is 30 squared, huh? So now I just solve that for b, and I'll have how far to the focus. So let's do that. Go to a fresh screen there. So 65 squared minus b squared is 30. What is 65 squared? Some big number. 4225. Is that right?
Yeah.
Minus b squared is 900. Subtract 4225 from both those. I'm in a weird mode here.
I got it down to my decimal.
So yeah, we want a decimal in the end. So I'm getting minus b squared is minus 3325. Divide by negative 1. B squared is 3325. Root it. Yeah, we want a decimal. So I'm getting
I got that number.
57.
0.6.
0.6628. I don't know how far they want me to round. Whatever. That's how tall they should make the ceiling from the from head level. 57.6628. Is that good? Does that make sense for the Whispering Gallery problem?
What number was it?
That was number, I didn't write it, did I? 20 what? 23, thank you. That was number 23. Yeah, 23, Whispering Gallery. 57.6628. Good, questions? Okay, so here is number
40 feet is going to be the
25. Okay, so they tell me that's an ellipse. So can you write the equation for that ellipse? So start by writing the equation for that ellipse.
okay.
It's 250 feet across.
Yeah, it's 250 feet across, 40 feet up and down. Let's see if you can write the equation for that ellipse.
So that means it's 0, 20, 0, 20.
Yeah, so we're going to write the equation. X squared over y, a squared plus y squared over b squared is 1. Yeah, so do we know what goes underneath x or y?
Yeah. The y-axis is going to be
So what goes underneath x? How far, remember x is how far right and left to the edges from the center.
20.
Yeah, half at $2.50 is $1.25, right?
Yes.
125 squared.
0.
Right? Because they're saying it's 250 all the way across. So from the center, remember A, B, and C are always from the center to the edges. So from the center, right and left is 125. From the center, up and down, well, if it's 40 all the way up and down, then from the center up is 20, down is 20, so this is 20 squared. We good there? So we have the equation of that oval shape, of that ellipse. So that equation, everybody good so far? What will that equation do for me? That equation will tell me the coordinates of any point on the edge. So let me draw the oval. So this oval has a bunch of points around the edge, doesn't it? And any xy point on the edge of that oval will make that equation true. Okay, so what do they, now to their question. What is it they want from me? I don't know if you can see that little diagram, but they're basically saying, hey, 10 feet from the edge, 10 feet, go in 10. We want to know this height here. See the question mark? Question mark. We want to know the total, how far from here to here at a point 10 feet from the edge. That's what they're saying. So at a point 10 feet from the edge, 10 feet off the edge, how high up and down?
So it'd be 115.
Exactly. You have to just think about what's the coordinates of this point? Can you just take that point right there?
Negative 125.
That point is back 115 up y. I don't know the y. I'm going to find the y. Isn't it? Because it's 125 to the edge. So 10 feet back from that's minus 115. Do you see that? That makes sense? Because it's 125 each way. So if it's 125 to the edge and they want 10 feet back from that, they want you to go back 115 feet. So they want you to plug in an x value of negative 115 and find the y value that goes with it. Okay, is that good? So take negative 115, plug it in there for x, so we'll get negative 115 squared over 125 squared plus y squared over 20 squared is 1. So, and then we're going to solve for y. We good there? Am I making sense? What we're trying to do. So I plug in the negative 115 for x, and I'll solve that equation for y. So let me go to a fresh screen, if you're good with that, and solve that. So minus 115 squared over 125 squared plus y squared over 20 squared. Okay, how do we solve that? Well, carefully. It's going to be a big number, so let's see. 115 squared. That's 13,225. Oh, did you do the whole thing?
I think so.
Yeah, okay, 0.8464. So I got this whole thing to be 0.8464 over 20 squared is 400, huh? Equals 1, subtract the 0.8464, and get y squared over 400 is 0.1536. Okay, now put this over 1, diagonal, diagonal, come up here. Y squared times 1, if I have room here, equals 400 times 0.1536 times 400. I'm getting y squared is 61.44. Root it. And I'm getting y is 7.84. Did you get that? Okay with all those steps? Y is 7.84. How are we doing?
Wait, did you get that number after you multiplied? Or you weren't?
This one?
No, I got that number.
Mm-hmm.
So now, is that the answer to our question?
Okay.
Oh, I forgot the one, the bigger one down from that.
7.84. Is that the answer to our question? Be careful here.
No. They want to know what the height is.
What do they want to know? Look at the question mark. Look at what they're saying. They want from here to there.
That would be y squared.
2 times y.
Oh,
Yeah.
Right? Because y, remember, y is from the axis up. So it's y up and it's y down. It's 2 times y. Does everybody see that? Right? Whenever you're doing what does an xy coordinate mean? It means from the origin over x up y. So y is just the amount from the middle up, isn't it? So that answer we just got, that's 7.84. That's 7.84. That's from the middle up. So you got to double that because they're asking for the top to the bottom. 2 times that, we'll finally have our answer. 15 point, I'll just say 7. 15.7. That was a tough one, huh? Does that make sense? So we have to double it in the end? Do you want to glance at the planetary problem for a minute? 6. So here's the center. They want me to find, so what they want the periapsis thing. Right? So they want this.
that's the focus point, right?
And so basically I've got an oval. I need to find, basically it's going to be A minus C. Everybody see that? Because A is from the center to the edge. C is from the center to the focus. It's going to be A minus C. So basically I got to find the equation, find A, find C, subtract them. Everybody see the game plan?
Yeah.
Right? Because they said this thing's at a focus. When I read it, even if you didn't understand all those words, this star is at a focus point. Right? Right? The stars, we orbit around the sun, which is a star. Right? But it's elliptical, so it's at one of the 2 focus points. It's more complex. But anyway, basically we do elliptical orbits. So that's a focus point. So the distance from center to focus, that's C. From center to edge, that's A. They want the gap from here to there. That's the periapsis, or how do you say that? Periapsis. And that's going to be A minus C, isn't it? Everybody see that? So let's write the equation. Mean 49. So this is 49. I already forgot the 54. That's this. Oops. Come on. 54. So apoapsis is 54. Mean 49. So 49 from there to there. 54 from here to here.
Just find the difference.
I'm getting confused now.
The difference between the apoapsis and the mean distance. Wait,
That's
that'll give you C.
yeah. So I think you're right, huh? Yeah. That'll give you C.
How would I get this?
Yeah. Look at the apoapsis for a minute. We're almost out of time. Yeah, this one's nice. We're not going to have to do too much work here. This is going to be a couple subtractions and we got it. Look at it. See the 54? Where's it going? It's going from here
To the middle.
to there.
The center.
Now, from here to here is A. Either way. You can go A either way, right? From the center, left or right is A. So
Isn't
the
that
54 is
49?
A plus C. See that?
Okay.
See that? Good observation Wendy is making. 54 is A plus C. What's the 49?
That's the other.
That's A. See, 49 is A?
Yeah.
Right? From center to edge. So A is 49. So,
54 minus 49.
see, that's what Wendy was saying. If you just subtract them, you get C.
Okay.
So now we got C. C is 5. And we've already got A. A is 49. C is 5. And the periapsis thing we want here is A minus C. So it's 49 minus 5. 44. Don't need to write equations. Just got to put those things on the graph. 44. Is that good? We solved that one. So we